Another experiment. This is with a salamander, a Japanese red-bellied newt. And the salamander would lay eggs. We put eggs in little chambers there and just watch them develop in space, looking for abnormalities when they're growing in a world without gravity. And they would be very much like little frog eggs developing into tadpoles and baby frogs. And what the scientists were looking for in this experiment, salamanders have a little balance mechanism called the otolith. You know, it's like our semicircular canals that we use for sensing acceleration and motion. And the salamanders and fish, frogs, they have something called the otolith. And the scientists were wondering what happens to that gravity sensing mechanism when it grows in space. What they found out in these experiments was it would grow about 2 or 3 times as big as it would normally be here on Earth. It was like the salamander was trying to sense gravity and it couldn't, so that otolith kept growing larger and larger up there. This is Chaki Mukai, the first Japanese woman in space, and I flew with her on my first mission. And in space, you don't walk around like we're used to here on Earth. When you want to move around in space, it's just a little push with your finger, and you go sailing through the air like Superman or Superwoman, and you'll keep sailing until you hit an opposite wall, until you reach out and grab a hold of something to stop yourself. If you like doing somersaults, you can just flip in the air all day, and you go round and round, and you never fall. And you just have a lot of fun, just effortlessly moving around up there. This is Susan Still, our pilot, and she's typing on a laptop computer. And I show this to kids. I said, isn't this the envy of how you'd like to work on your laptop instead of in one of those uncomfortable chairs? You know, you can just be floating in the air like that, typing away. It's really a comfortable environment. And in space, there's no up or down. You know, wherever your head is pointed in space, your brain says that's up for you. And wherever your feet are pointed, your brain says that's down. So this is Nancy Kerr and Kevin Kriegel from my second flight. Nancy's looking at Kevin saying, hey, Kevin, you're upside down. Well, Kevin's looking right back at her saying, no, you're upside down. In his little world here, she's the one who's upside down. You know, and as you move around inside the shuttle, however you have your head pointed, your brain makes that up. So you never feel like you're upside down. It's everybody else in the room. You know, it's a very egocentric view that the astronauts have. This is our food station. We don't have a refrigerator, freezer, microwave oven, nothing like that. So all of our food is freeze-dried. It comes in small packages like this. This is cream spinach, but we got 150 different food items that they fly. And it's all freeze-dried, so it's lightweight. It'll stay preserved a long time. When you get to space, you bring it to a little food station. There's a needle. We poke the needle into the package, inject hot water in there. The dry food will absorb the water, and after 3 or 4 minutes, you just cut it open with a pair of scissors, and it's ready to eat. And it's not good food. It's like okay, kind of like camping food. But I can never wait to get home and get a hamburger or a slice of pizza, some decent food after a space mission like that. And in space, we don't drink out of cups or bottles. All of our drinks come in little foil pouches like this. And this is a bag of powdered orange juice. And again, we take it to that food station, add water in there. You can mix it up, poke a straw in there, and just squeeze it into your mouth. I bet David has drank out of little packages like that, right? Like a little juice bag or juice box? Could be. But that's how we drink in space. And here I have a drink bag of tropical punch, and I squirted some of it out. And what looks like a little red golf ball in front of my face is a blob of tropical punch. And it's from surface tension, just drawing that liquid down to the smallest possible volume, which is a sphere. And it'll just float there in front of you. You can take your straw out, poke it in there, and suck on it, and it'll get smaller and smaller and smaller and disappear there. Sleeping in space is a little different. We don't have dedicated bedrooms on board the shuttle. So when it comes time to go to bed, you just take a sleeping bag and attach it with a couple of clips up on the wall like that. You just float up, slide inside the sleeping bag, and go to bed. We've got these dark blue straps around the waist. You can tighten these down and it'll pull your back up against the wall of the shuttle. And it puts a little pressure on your back to make you feel like you're laying on your mattress at home. Because if you're just floating in the air and you close your eyes, something doesn't feel right. You're so used to pressure on your body, even if you have the softest pillow top mattress in the world, there's still a lot of force on your body. And when you take that away, it feels really, really strange. So we tighten out those straps, pulls your back up there, puts a little weight on your back. We also have an elastic band that goes around your forehead, and it'll pull your head back into a pillow as well for that same reason, just to put a little pressure on your head to make it feel a little more normal for you. And see, we wear eye shades because you go around the Earth every 90 minutes. get 45 minutes of daylight, 45 minutes of nighttime, and if you don't want the sun coming in your eyes all the time, you wear the eye shades. And you tuck your arms in like that so they're not floating around, maybe hitting some of the cables, doing something bad in the middle of the night. So you just try to get nice and snug like that. And there's another sleeping bag right above it, so this is like a double-decker. And most of the astronauts, at least one night, they'll put their sleeping bag up on the ceiling just so you can come home and tell your friends, I slept up in the ceiling one night of my life. Okay, on board the shuttle, we don't have a shower, we don't have a bathtub, we don't even have a sink like you have in your kitchen or bathroom at home. So when it comes time to clean up, we have some of this, like these drink bags, and instead of having powdered juice in them, a few of these will have powdered soap. We can add hot water, mix up a bag of hot soapy water, put it on a washcloth, and give ourselves a sponge bath. That's how we clean up. To wash your hair, we have this special shampoo called No Rinse Shampoo. And this stuff was developed for people who are in the hospital that can't get out of bed to take a shower. And all you do with this stuff is squirt it in your hair, you work up a lather, and then you take a towel and pat it dry, and you're done. And I took this picture. I love the bottom line on that bottle. It says, for beautifully clean, full-bodied hair. And I just wanted to share with you what that looks like. That's Susan Still, our pilot. Anybody with longer hair, it's just going to float all over. Okay, exercise is really important up in space because we don't use our muscles at all up there. To move around, it's a little push with the finger to move, a little push to stop, and everything is weightless, so you're not using your muscles at all. We have a little exercise bike that we ride up there every day for about 45 minutes or an hour. And it gets your heart muscle going, gets your leg muscles working up there, so that when you come back to Earth again at the end of the mission, you're in some kind of decent shape. For the astronauts up on the space station, they exercise 2 to 3 hours a day. And even that is not enough. They come back with weakened muscles and loss of bone density. We're getting better and losing less and less bone density on these missions. We're still learning how to minimize that, but it's still a good issue for us. This is the toilet on board, and the toilet's in a small closet area, maybe about 4 feet across and 5 feet high, and there's a little curtain that goes across the front of it there. And it's got a toilet seat right there, just like our toilet seats on Earth. But here on Earth, we use gravity to collect the waste material in a toilet. In space, everything floats. And that's a problem for us. So this toilet is kind of like a porta potty that you'd see at a football game or a construction site. And in the bowl part of the toilet, we have giant fans. And when you want to go to the bathroom, there's a little knob here at the side. You push that forward. It activates the fans, and it sucks air from the toilet seat downward. So we use this continuous downrush of air in the bowl part of the toilet to kind of act like gravity to keep the waste material down there. There's a couple places here to put your feet into. There's a couple of bars that come down. They clamp on top of your thighs. They kind of spring-load it to hold you down in the toilet seat so you're not floating all over when you're trying to go to the bathroom. My favorite part of this picture is right here. This is a little cue card with the procedure for how to go to the bathroom. And I might have just blown every image you had of an astronaut there telling you that, but we have a procedure for absolutely everything on board the shuttle. The only thing we memorize are what do you do in case there's a fire, or what do you do in case there's a cabin leak.